Hello, everyone. Thanks for joining us today. I'm Dawn Parzak. I'm a developer advocate at LaunchDarkly, and today I will be speaking with John. John, I will let you introduce yourself.
Hi, I'm John Kodumal. I'm the CTO and co-founder of LaunchDarkly. We started, my co-founder Edith and I started LaunchDarkly about 5 years ago. Prior to founding LaunchDarkly, I was at Atlassian for 6 years, and prior to that, I was at a company called Coverity.
Nice, thanks. So for those of you listening in today, if you have questions that you would like to ask John, please fill them out in the GoToWebinar control panel, and we will address those questions at the end. So the background of this talk is, John, you wrote a piece for StackShare recently about our architecture and the changes that have been made over the last 5 years. And it was really interesting to me to see how things have evolved. So we've got a couple of questions for you based on that and some other things that curious minds want to know. One of the most interesting pieces in the article to me was how our not invented here syndrome philosophy has changed over the years. Build versus buy debate is something that everyone faces. So how have we shifted our beliefs in that realm over the last 5 years?
Yeah, that is something that we have significantly shifted over time. I think the right answer kind of depends on the nature of your business and what you're producing. For us, when we started the company, we had a lot of uncertainty or questions about the idea of a feature flagging, feature management solution as a cloud-hosted solution, and we were also kind of fairly new to AWS, actually, and so our selection of AWS, one of the things that we wanted to think about was remaining cloud agnostic. So we wanted to build a system that would work on AWS, but avoid vendor lock-in and potentially allow us to move to other cloud providers or even offer like an on-premise or self-hosted solution. And so we really focused on using just the barest sort of like cloud capabilities, like EC2 compute, basically. Anything besides that, all of the higher level services, especially ones that might require application code changes to migrate or things where there aren't equivalents on other cloud providers, we avoided. And what we learned, I guess, in the first year of operation is that just by using even compute resources like EC2 instances, you're building sort of institutional knowledge, and there's a kind of vendor lock-in that you're accepting by having that institutional knowledge or expertise in that particular cloud platform. So even with us using EC2 instances, after about a year, it would have been expensive already at that point to shift over. And that's when we kind of had more confidence in our model. We understood that we were going to be a cloud solution, and we had built enough risk mitigation around other aspects of the platform that would allow people to trust us as a cloud-hosted solution. And that was when we shifted our thinking. So we shifted into a model where we started using some of the higher level services, things like DynamoDB, hosted Postgres instances, RDS, application load balancers, things like that. And from there, the shift for us was some of the challenges that we had, I suppose, were kind of around cost. We moved into a model where instead of thinking about like the bare compute resources that we needed to run something like a load balancer, we went into variable cost models and having to estimate how much a particular service that we were using, like read provisioning, all the different aspects of Amazon cloud spend were impacting our COGS. And so we ended up building sort of fairly sophisticated cost calculators in-house that allowed us to think through the spend. Like overall, I think if you look at the raw dollar cost, cloud services are often more expensive than self-hosted, but when you count in the opportunity cost for your time, for your team's time, then the equation starts to shift in the other direction. And now we're using a large number of Amazon services, things like application load balancers, Elasticache hosted Postgres, things like that.
Great. You mentioned risk mitigation. Anytime you hear cloud, people think, oh, that's scary, that's risky. What are some of the things we've done to mitigate some of the risks of being a cloud-only solution?
Yeah. sort of like architecturally, we protect our customers from any sort of like network partitions or incidents on our side. We do that through like our SDK model. So we allow our SDKs to fall back to customer-hosted databases for feature flags if necessary. We use multiple layers of redundancy, things like CDNs to cache data when if there is some sort of incident. We're also using feature flags in kind of interesting ways on that front. So we have some of our services. In the operation of our service as a whole, we sometimes use third-party services, and we can at times feature flag those. So for example, we use a tool called Send With Us in conjunction with, I think it's SendGrid, I think, as our mail sending solution. But we also have that feature flag so that we can fall back to SES in case which is Amazon's hosted mail service, in case there are any problems with those providers. So the cloud is about us hosting in AWS, but also our trust in third-party vendors like Send With Us, like Segment, and other tools like that. And we use feature flags to potentially mitigate risk in those situations as well.
Very cool. So can you share with us an architectural or technology decision that didn't turn out the way you thought it was going to?
Yeah, this is a somewhat embarrassing one because it seems pretty obvious now in retrospect, but in the earliest days of LaunchDarkly, we underestimated how much sort of like expertise there was in building health checks. So some of our services, we started building health checks around. We have a microservice style architecture, so we have a lot of individual services that sort of had dependencies between other services. And so our first cut at health checking, we built this like extremely overcomplicated health check system where each service sort of checked its downstream dependencies and reported their health as either in the critical or non-critical for operation bucket. And so what we ended up with was essentially building this sort of like service health dependency graph, and like one service check would like query all of the other services in the mesh. And this was really bad for several reasons. I mean, as you can imagine, it's really obvious now to think about, but we basically built in the perfect system for cascading failure. So like one system would come down and this would create all these emergent behaviors of other services popping in and out. And we realized that simplicity is best when it comes to health checking. We also just didn't quite optimize like the frequency of health checks appropriately. So one of the health checks that we did, we call this incident the smooth criminal in retrospect, because we had one service that was calling another and just saying, "Are you okay?" Like, "Annie, are you okay?" over and over again. I think it was like every 100 milliseconds with a check that we thought was benign, but would take like 25 milliseconds or something like this. And it turned out that like 10% of that service's overhead was just like responding to health checks. So we got much better at that. But it's amazing how much of an art it is to actually health check things appropriately in a way that maintains resilience and avoids cascading failures.
Mm-hmm. So it kind of leads me to the next question here, and in terms of what processes and solutions we have in place for reducing downtime and system failures.
One of them, I think, which is somewhat boring, I think most people would say, but we have a really good incident management process. So we talk to the whole team about like what constitutes an incident. We have very clear severity guidelines. We've informed the entire company that incidents aren't just things that are reported by engineers. Incidents can be service outages or issues like that, but they can also be things that are observed by any of our staff at any time. So anyone in the company is empowered to declare an incident. We have like a /incident command in our Slack, and this is really powerful because pretty much everybody in the company has eyes and ears on the things that are happening in the company. They're trying out the product, they're demoing the product, and while we do primarily rely on our DevOps team and our alerting systems, as you would imagine, sometimes a customer or a user on our side, somebody that's demoing our product at a conference, might see something, and they can declare an incident. Incidents also are things that happen outside of the service operation, things like bad press or things like that, and empowering anybody to create an incident is a really powerful thing within an organization. once an incident is declared, we have a pretty comprehensive process that kind of gives us all the steps that go on during an incident. So we have an incident quarterback, an incident manager. We pretty much follow a process end to end. It sounds heavyweight, but one of the things we've done is sort of tailored it for different severity levels. So at the lowest end, it does end up being a fairly lightweight process. But on the high end, we do all the good stuff like post-incident remediation. A lot of this was driven by some of our certifications. So we're SOC 2 and ISO 27001 certified, and those sound like boring things, and they sound like things that you might just do as a checkbox measure to get through like this security reviews with prospects and so forth. But we found that by going through those processes as an early stage startup, we were able to come in greenfield and kind of tailor our processes to allow us to move quickly, but still meet the requirements of the certification. So overall, those things I think were very positive for us. Other tools besides having a really strong incident management process in place, and I should also say, like on the incident management process, we're starting to see tools come up around that incident management process, which I think is really cool. For example, like Fire Hydrant is a tool that we've seen that kind of packages up our process, which we're kind of doing end to end and have devised ourselves into a single tool, and that's really cool. Other things that we do to reduce downtime and system failure, we have really good change management tools. So we have a homegrown solution that we call our change log, and that's like basically a catalog of all service level changes that have happened. And those can be from feature flag changes, deployments, infrastructure changes, which we all manage through Terraform configuration as code. And that makes it extremely easy to go from potential incident or potential service level issue to the change that might have caused that. We use feature flags very extensively. So most of our changes are feature flagged, and those are done for canary release purposes, as well as long-term controls for operational features. So we can shut something off if we're seeing impact from that at any time. And then finally, like observability tools are extremely important. So we use tools like Honeycomb and Graphite and Grafana to monitor the state of the system at all times.
Great. Yeah. I mean, part of my background is in the monitoring and observability space, and when you're dealing with high levels of change, you need that visibility into what's changing and the impact that change has had on your systems and in consequence your users. So when we're looking at kind of those changes, you mentioned a couple of tools. How are we kind of tracking that change and the impact those changes are having?
Yeah, I think that, just, I guess, thinking about it holistically, we go from knowing what changes there are, which we use our change management tool for, to, being able to impact that change. So if a change is feature flagged, for example, we can shut that off. But prior to that step, it's about observability. So essentially going from a change to the observed impact of that change and the controls necessary to mitigate that change. That sort of like end-to-end process, having tools in all three of those arenas is kind of super important to us. Honeycomb right now has been extremely valuable for us in that regard. So there's features in Honeycomb as a monitoring and observability tool that really allow us to like isolate the impact of, say, a particular customer on the service really quickly, because we can do like outlier detection very effectively.
Very cool. And kind of following up with change, like what's a small change that we've made that ended up having a really big impact on the product or the company?
Yeah, all the way down to like the smallest kinds of changes that you can imagine. We put in these two code patterns, I call them like micro patterns, that really helped us with dealing with like stampeding herds in the system. So we called those read coalescing and write coalescing. So read coalescing is this idea, it's a kind of like caching or memoization technique, and it's really tiny. Like there's a Google library that implements this, where like the Go code for that like fits on one screen basically. And the idea is basically if you have a stampeding herd of requests coming in for the same resource, you can essentially memoize that. So you can force everybody to wait for the first response back from the database. So if n readers are coming in trying to read the same piece of data, you can just have them await the first database response instead of making n database requests for the same query, and then you return that. That's a tiny pattern, but that was massively impactful, especially at the scale that we're at. The dual of that is something called write coalescing, or we call it write coalescing, and that was another pattern that we implemented where some of the write patterns that we have like enormous amounts of data coming into the system, and we're trying to infer some behavior. So we're sort of like, we're looking at maybe 1,000 pieces of data coming in per second, and like the last one wins. The last one is the piece that we want to write, and so we'll memoize the writes because we can discard all of them but the last. So we'll kind of start queuing things up until the write finishes, and then when we're ready to write, we just write the last one. Those seem like really small changes, and in fact they kind of were, but they made massive impacts to the system in terms of uptime and availability as we scaled out horizontally.
Oh, that's great. I'm going to switch gears a little bit and ask you kind of maybe a little more personal question here. As somebody that's constantly, learning and reading books, I'm curious, what books, publications, podcasts, whatever you like to listen to when you're not, running a company or taking care of your kids.
Yeah, I read a lot on engineering management and engineering organization. I think as we scale out the company, I think people sometimes aren't as intentional about like the requirements around management and how much sort of knowledge there is about building systems at scale. So like Andy Grove's book is a great example of that. But more recently, a couple books that have been very influential to me are Lara Hogan, who is the former VP of engineering at Kickstarter, I believe. She wrote a book called Resilient Management, which I think does an amazing job of marrying process to like empathetic management of people. So I really recommend that. Another one is a book that was published recently by Will Larson called An Elegant Puzzle. And that one kind of captures a lot about the way we structure our engineering organization and some of the like sort of like invariants that we have at scale. So I recommend those two. For podcasts, most of the podcasts I read or I listen to are like in the car with my kids. So they're kind of like kid focused. One that I sort of like because it's enjoyable for adults as well as kids is this is one called Smash Boom Best, which is like they pit two things against each other. So it's like invisibility versus flying, like what's the best superhero power? And then kids kind of debate that. I like it because they have segments on there that kind of isolate sort of like, anti-patterns in debate processes. And so you learn about like ad hominem attacks and things like that, things that you want to avoid, circular reasoning, different kinds of logical fallacies that people employ during debates. And so it's interesting to read about that and to expose my kids to it. They're like 3 and 5, so I don't know how much of that is sticking.
That's cool.
It's a cool podcast.
Yeah, I'll check that out with my son. We've been listening to Way of the Warrior Kid podcast. Awesome. Yeah, it's based on a book series that he read. The author now does a podcast, and it shows kids how to be, little warriors and combat difficulty. So that's a cool one. He enjoys that. So
very cool.
This sounds like something we can check out as well. We recently passed a milestone, and we have now over 100 employees. And it's very different having, hitting that milestone. Things from when you were, 3 people aren't the same as when you have, 100 employees. How, as we've grown, have you created an environment within the engineering department and the organization for our career growth?
I think it's really interesting. We are a really fast-growing company. We're just about doubling every year in terms of headcount. But when you think about that, the opportunities to move into like management roles are actually more limiting than you might think. We're doubling every year. There are companies that go from like 100 people to like 1,000 people really rapidly, mostly like in the B2C side where that kind of rapid growth is more feasible. For enterprise companies, growth tends to be, even at fast-moving enterprise companies like ours, growth tends to be a little more deliberate, let's say. So doubling year on year, when you actually like break down the math, that doesn't actually imply massive numbers of new managers that are coming on board. So I think the first thing that we think about when we think about giving people career opportunities is recognizing that career growth is not just about titles or moving into management, and really thinking about career growth from the perspective of learning and contributing and making impact. And so when we shift people into that, and that kind of permeates into things like our review cycles, where we're talking about not just like mentoring, but also things like what it takes to actually move up a level in terms of contribution, impact, and trust on the projects that people work on. I think that more companies than not are in that position of having to articulate growth in terms of things other than just movement into management roles. When you think about the math, like the numbers kind of bear that out. And it took us a little bit of time to actually like learn how to articulate growth in those sort of less tangible ways. It's very easy to say like, okay, you're at this level, and then you'll be a manager level 1, or you'll be a team lead, and then you'll move into engineering manager. But unless you're building an extremely hierarchical organization, you don't need that many engineering managers. At our engineering organization, I think we basically have 3 engineering managers, and then a handful of team leads under that. And most people are ICs, and I think that that's a healthy and more effective way to run an organization.
Great. One of the things that really drew me to LaunchDarkly as a company was the company's values and cultures. You mentioned one of them in this environment of continuously learning. And it's great. Like, as the company has grown, like, how do you make sure that our culture and the values are being maintained as we have more and more people join us?
I think at this size, there's enough visibility into like the founders where we can still set an example. So I think one of the things I think about is like when we started the company, I had a 6-month-old, and so by design, we had to build a system that would work for people with young kids, or people that needed time off, people that needed flexibility. My wife is a doctor, so like when she has an incident, people's health is at stake, and so we have always had this understanding that her work is extraordinarily critical, and there would be times, even at a 4-person startup, where what I was doing was critical, but not as critical as what she was going through. So we started out early, kind of baking that into the culture and making sure that it was not something that was special to a special privilege of the founders, but rather the way that we operated. And I think we're still at that size where setting examples from the top works. The other side of that is bringing people in that share those values. And so, this is not secret sauce or any kind of magic, but during the hiring process, culture is an extremely important part of the interview process. And we bring people in that share those values of, having work-life balance, understanding that what we're doing is critical, but at the same time, there are other things in people's lives that are happening that we need to be. We think about our employees and the growth of the company in the long term. Like it's a marathon, not a sprint, and so we want people to stay with us for 5 or more years. Which 30 years ago, it wasn't much time at all. But now in Silicon Valley, that's an eternity. And so we think about investing in our people and helping them grow all along the way, and understanding that sometimes things go on in people's lives and they need to take a week or 2 off for personal reasons, and that's totally fine. Another aspect of sort of like the way we lead from at the founder level is I've never really understood the necessity of working extraordinarily long hours. I think people become less effective, as they work over time. Like people do their best work in sort of like punctuated spurts, and we've built an organization that kind of believes in that as well. So it's not about people sitting in their chairs for 60 hours a week to fill up 60 hours a week. It's about choosing smart work and attacking that with a deliberate focus.
Mm-hmm. No, that's great. As somebody that is very creative, I do a lot of writing. It's like, and once I'm, tapped out, it's like, there's no more words left in me. Like, I could sit at my desk for another 2 hours, but I'm not going to write another word after that. So having that flexibility is really great as an employee. So thank you.
Yeah.
As you make technology decisions, have you had to say no to, a technology or an architectural change because it doesn't align with the culture and the values that we're trying to foster as an organization?
Yeah, I think one of them is around our. I guess one value we have is around like the product culture, right?
Mm-hmm.
We're a product-driven company. That means a lot of things to a lot of different people. I won't pressure myself into providing a definition right now, but part of being product-driven means that we need to move quickly, and so we use our own product, like it's kind of an integral part to the way that we deliver software, and that is all predicated on us being a cloud service. And there are some organizations for whom using a cloud service is just not possible. They need to be they're in air-gapped environments. They have software that is just disconnected from the network, and we've been approached by those companies for like an on-premise model. If we were to make that technology choice, it would fundamentally shift how we deliver software. We would have to support older versions of our software for customers. I mean, everybody kind of understands the difference between cloud-hosted software and self-hosted software. And if you think about how that fundamentally changes like the way you deliver software, that would negatively impact us in a pretty substantial way. So we've pretty much doubled down or tripled down on the understanding that yes, we're a cloud service, and yes, you can trust us. We have massive amounts of proof that that is a way some pretty amazing Fortune 100 organizations run, trusting us for everything that they do. And I think we had to stick to our guns in some cases and turn down some possibly very significant deals in order to maintain that.
So we talked a lot about kind of the past and what led us to here today. What does the future hold for LaunchDarkly, and the next 6 to 12 months? What forward-looking things can you share with the audience about what's coming with LaunchDarkly?
Yeah, we're at a really exciting point in our engineering and product delivery organization. We're amazingly, we're shipping faster than we ever have before. We've scaled out the team, and now we have this amazing product management team, an amazing design team, in addition to like this engineering core that we've always been strong at. And things are coming out really rapidly. I think at our scale, sometimes it's really easy to sort of start shifting the balance and focusing more on maintenance, or being in a situation where there's a massive amount or a significant amount of technical debt that you need to address. We're fortunate that we're not in that situation, so we're still moving extraordinarily quickly. In the next 12 months, some of the things that we're building that I'm really excited about, one is we're going multi-region with our flag delivery service. So the flag delivery service is the piece of the infrastructure that actually is responsible for delivering feature flags. So we have this unique architecture where when you connect to LaunchDarkly, we maintain a persistent connection to LaunchDarkly, or your servers maintain a persistent connection to LaunchDarkly. So at any given time, there's about 11 million mobile and browser clients connected to us, as well as about 2 or 3 million servers connected to us. And so they're connected primarily to US East 1 right now. We're moving out into a world where we're distributing that across regions around the globe. Think of it as a content delivery network that is optimized and specialized for feature flag delivery. That's like the secret sauce that allows us to deliver feature flag changes in 200 milliseconds. And that's going global. So we're really excited about that infrastructure change. It makes us more resilient and leads to just faster delivery time and for our feature flags. We're also focusing really heavily on workflows. We're starting to see some pretty massive organizations using us at scale. And this means an engineering team of, say, 1,000 to 2,000 engineers using our product. And the scale requirements in terms of workflows that those organizations have is very different from a smaller organization. Nevertheless, the things that we're building will benefit almost anybody. But these are things like focusing on features that allow you to eliminate the technical debt associated with feature flagging, workflows like approvals, just sort of some of the core things that you think about as you manage feature flags at scale. There's a push towards that. The last thing that I think is really interesting is this idea of using LaunchDarkly everywhere. We have this belief that feature flagging is a fundamental aspect of continuous delivery, and anybody building any network connected piece of software can benefit from using feature flags. So right now we're used primarily by companies on the web and on the mobile side of things, but we're starting to see use in OTT devices like Amazon Fire Sticks, Roku boxes. We're releasing support for LaunchDarkly on C and C++, both on the server and on the desktop. We're envisioning a world where, in the not too distant future, where no matter what you're doing, if you're using Erlang, you're using Rust, you're using something that I've never heard of today, there's a LaunchDarkly SDK for you, and it's supported in LaunchDarkly in a first-class manner.
Great. So we have some big goals and hopes for world domination and feature flags everywhere.
Yeah, very positive.
Yes. I think one more question, and then we'll see what the audience has. So if you would like to ask a question in the GoToMeeting chat box, type in your question. We recently passed 300 billion flags a day that we're processing. That's a pretty big metric when you think about it. What are some of the other metrics that you care about from an organizational perspective that shows that we're heading in the right direction?
Yeah, I think there's a good number of them. The first thing I'll say is like that metric, the number of feature flags per day. It is in some sense a vanity metric, but I think it's really interesting to us because that scale shows that we're being used not just for human interactions with a service, but also machine-to-machine interactions. That penetration, that growth in that number means that more people are using LaunchDarkly for many of the use cases that we envision. For example, like APIs that are feature flagged. So feature flag, the word feature flag is kind of a little unfortunate. It's misnamed. Feature flags are not something that you just use for user visible features. They're things that are used for managing change and delivering the smallest units possible of change and having flexible control over that change. So when we see 300 billion feature flags a day, we get excited because our customers are using us in the way that we really imagine. There are a number of other metrics that we look at. We look at the number of concurrent connections to us. We look at core metrics like the time it takes to update a feature flag because, again, we're used as a critical piece of infrastructure. We don't use this polling architecture. We use this streaming architecture. We need eventual consistency, and we want that to happen in under 500 milliseconds, and we're hitting that at about 200 milliseconds right now. So that's kind of a critical one. I think at the top level, customer satisfaction, like things like NPS, are really, really important to us. We look at that as kind of like a leading indicator of how we're doing overall. Again, we are a mission-critical piece of infrastructure, so if people are having reliability problems, sometimes our observability tools don't pick up everything. What a customer is experiencing might not be what you're picking up on your monitoring system, and so you need to look at those top-level indicators, like what are people saying about your reliability? What are people's experiences integrating you and using you on a day-to-day basis? What problems are they having? We're an extremely customer-focused organization. And so when we have support questions, when we get NPS feedback, our engineers are extremely motivated to come in and help and think about how they can improve the product to make those things better. I guess those are some of the top-level metrics. Overall, we have this sort of suite of service level objectives that we think about for the entire service. We define those sort of both in terms of like how we're hitting them today as well as aspirationally where we want to be. We do like a quarterly OKR-based planning process, and one of the things that we do is around each of those service level objectives, if we're not meeting that objective, we think about we prioritize the work required to get us to that objective as quickly as possible.
Great. So that's everything I had for you. Let's see what our audience has.
Okay, so our first question is, can you share a kind of the most memorable incident or outage that you had? Story time.
Here's a fun story. We like to think of funny names for our incidents, so we had the smooth criminal, the Annie's you okay health check thing. Another one we had, we called it the Shatnering. We had an incident called the Shatnering. So what happened was we changed our load balancing infrastructure, and we did a massive amount of testing on this. And it turned out that with the new load balancing infrastructure, at a certain byte boundary, and it was like if the response was between, I think it was like 70 bytes and like 250 bytes or something like that, the new load balancing infrastructure would send the first half of the payload and then pause, a very pregnant pause of like 2 or 3 seconds, and then it would deliver the rest of the payload. So the response would come in slowly, the way William Shatner talks. And so we called that the Shatnering, and it was incredibly difficult to diagnose because the vast majority of our customers didn't happen to have a payload that fit into this very precise byte boundary. But when they did, they were observing this latency that was completely unexpected. It took us a while to reproduce this, and it turned out to be something at the cloud level where eventually our cloud provider that was giving us these load balance, that provided these load balancers for us, actually found a bug in their infrastructure and feature flagged us into the fix. So a pretty amazing use of feature flags, and then it took about 3 months for that fix to land in general availability for all customers of that service.
Nice. The next one is, how did you convince investors to invest so much money into feature flagging service? Did you pitch a larger vision?
We did pitch a larger vision, yeah. You know, I think the first thing that people think about when they think about feature flagging is like, isn't that an easy problem? I assure you it is not. But I fell into that same fallacy. When Edith and I, my co-founder, thought about the problem, my first response was like, I will build that in a weekend. And I tried, and 5 years later, I have failed. And you know, when we talked a bit about build versus buy at the start of this conversation, and that's a conversation we have with a lot of our customers. They think about building this, and then they look at some of the things that we've done, and they realize they don't necessarily want to solve those problems. When it came to convincing investors, a lot of investors have, you know, they do due diligence, and part of the way they do due diligence is they talk to people that have been at other companies, and they see if this is a problem that they've faced. And so some of our investors talk to people at like companies like Facebook, Dropbox, Netflix, and they'd ask like, what are you doing for feature flagging? And they'd be like, oh, it's a solved problem for us. Yeah. We built this thing. And then that's sort of a really leading question, like, okay, so how long did you spend building that thing? If you look back, there are blog posts about these sort of these great code name systems like Gatekeeper or Gandalf, other tools that have been built. None of them were really open sourced, and there's great blog posts about how these have transformed things. So at those extremely large organizations that have had the opportunity to invest significantly in feature flagging, they've seen the impact. Then it's sort of like, well, what about everybody else? Mm-hmm. You know, we have customers that are in Silicon Valley that are sort of like the cool kids, technology leaders, but we also have, you know, insurance companies, airlines, food delivery organizations, old school restaurants, all using our software. It's because of that story of like software eating the world. Every company at some level is a software company now, and not every company wants to spend their time building infrastructure like feature management. So that's, I guess, a long-winded answer to how we convinced investors that feature flagging was an important system that people needed.
The cost of API gateway for 2 billion requests would be very high. Why not host your load balancing using Nginx? What is the thinking behind this? Yeah,
we don't use API gateways specifically for that reason. We use ALBs. The ALB costs end up being significant, like in the I don't know, 5-figure range a month for us. But compared to the costs of hosting, we were using HA proxy or hot proxy. The engineering costs to maintain those at scale, especially with some of the requirements we have on long-lived connections and auto scaling and things like that, the build versus buy equation kind of tipped in one direction there. But you bring up a really good point. Cost models for some of these services don't necessarily align with what you're doing. And so whenever we onboard, especially a variable cost service or a cloud-hosted service, we have to project out what those costs are going to be for our particular use cases. So API gateway makes no sense for us. Even 4 years ago, we actually did some pricing comparisons on using something like API gateway, and we were in like the tens of thousands of dollars a month at a point when our ARR, that would have been a significant fraction of our ARR, frankly. You know, and that doesn't mean that their pricing models are wrong. It's just that their use cases don't align with the usage patterns we see in particular. So we're very deliberate about COGS calculations, cost of goods sold calculations. We try to be at the 80-20 rule, so 80%, 20% of every dollar we take in is spent on cloud services, and we have to ensure that everything we build out is priced in a responsible way where we're not losing money, and also doesn't have the potential for unexpected spikes in spend that no longer align with our COGS. So it's a fairly challenging thing to do. I mean, there's a suite of tools out there that are just around managing cloud spend, and we've done a lot in-house because a lot of the things that we've done predate that spend, but like things like using Athena, things like pushing cloud spend into like essentially BI tools so that you can monitor and manage that. That's something that you have to do at some point.
How did you avoid accumulating technical debt and maintaining your velocity up until this point?
For us, we think about, so I mentioned that book, An Elegant Puzzle. I like the thinking in that book because it's very sort of like constraint-based. And we do that kind of constraint-based modeling for when we think about the overall planning of our engineering organization. So one of the things that we've done is we've said, over time, the percentage of time that we spend building new features versus the percentage of time, we call it KTLO, keeping the lights on, should be at a particular number. For us, it's like 50-50 or something like that. This changes through a company's life cycle. So earlier on, before we had any customers, for example, we were at 100% of our time building new functionality. At some point when you become much more mature, it becomes impossible to spend 50% of your time building new functionality versus keeping the lights on. Right now, that feels like the right ratio for us. So when we think about technical debt, we think about, instead of doing these sort of like extraordinary efforts when things have gone really bad, we think about keeping ourselves maintained in a good, healthy state. For example, we have an initiative right now, an example of where we haven't done this so well, we have an initiative right now to modernize a lot of the drivers that we're using. It turns out we've gotten pretty far behind on some of the database drivers and other drivers that we're using, and so now we have to do this extraordinary effort to keep all of those up to date. If we'd spent a little more time keeping the lights on, we probably would have done that in a more gradual way. And so fundamentally, it's about knowing what percentage of time to spend on technical debt and maintenance and forcing yourself to adhere to that in planning processes.
Can you give a little bit more information regarding technologies that go into providing the 20 millisecond, 200 millisecond update SLA, if that's okay to share it?
Regarding the technologies that go, oh yeah, certainly. Like that's actually on the build versus buy front. That's something that we had to build ourselves. Again, we had there's some more details in the StackShare post, but we used a service called Fanout initially. Fanout is a service that can handle persistent connections very well, but its pricing model was more aligned with things like real-time chat, where the scale was just wildly different. Also, connections in that world would be more short-lived, like something would connect for an hour and then disconnect, right? A model more like Slack than LaunchDarkly. And what we had to optimize for was very different. We had to optimize for servers connecting to us 24/7, where the number of messages being sent was relatively small, and in terms of frequency and in terms of scale or size, that's very different from like the traffic pattern you see in like a chat client. So when we started growing out, the fan-out pricing model didn't make sense for us anymore, and so we in-housed that. We built a Go microservice that handles persistent connections. It's actually a rather challenging task. There's a lot of blog posts about how to do tens or hundreds of thousands of concurrent network connections on one box at scale performantly. I suggest you can go read up on some of that. A lot of the tricks in those blog posts we used to produce we call it Streamer. That's the microservice that does the persistent connection handling for us.
How frequently are your code releases, and how do you keep change management up to date?
We do a very continuous code deployment or release process. So we use feature flags for almost everything. We have a microservice-based architecture, and pretty much anybody is empowered to deploy at any time. We do multiple deploys per day. We do automated deploys for any merge to master on staging. So there's a massive amount of deployment happening to staging, and then probably maybe 2 or 3 times a day we're pushing to production, but a lot of that risk is mitigated through feature flags. Any kind of issues on half-baked code or whatever, we can just feature flag those off.
What are the real major LD value propositions when it comes to competing with free feature flagging solutions?
Yeah, I think the free feature flagging solutions, they make sense at a scale, right? For example, I'll compare LaunchDarkly to something like open source. Tools like Waffle or Flagger, they're great at a certain scale. Where a tool like LaunchDarkly becomes extraordinarily valuable is when you think about expanding that process to a large development organization. An analogy that I like to use is it's like Git versus GitHub, right? Git is a free solution. You can use it effectively at a small team, but what makes something like GitHub extremely valuable as a layer on top of Git is team collaboration. So when you have a team of developers that are using feature flagging as a foundational mechanism to their code deployment process, you need to communicate about those changes. You need to allow non-technical users to make those changes. You need all the change management that I talked about with respect to other aspects of the development process. You need that for feature management, and that's where we become extraordinarily valuable.
How do you deploy with zero downtime with so many persistent connections?
That's a real challenge. What we do is we do slow drains. It actually takes us now, I think, about an hour to actually drain all of the connections off of all of the old boxes and onto the new boxes. And the slow drain is to avoid essentially like a connection storm or a stampeding herd of new connections onto the infrastructure. So that's extremely important. We have a pretty modern deployment system now that took quite a bit of work. We use Spinnaker for our deployment system, and Spinnaker has kind of helped out quite a bit with that more complicated deployment process.
Who in your organization physically enables the feature flag for Canary launches? Is it with product management, dev, delivery teams?
It depends on the why we're feature flagging. Some of the things that we feature flag are operational in nature. So for example, those read coalescing, write coalescing capabilities I talked about, those were actually feature flagged when we launched them. And so that was done by the DevOps team. New functionality, actually PMs will do a lot of the feature flagging for that. If the use case is around sort of a traditional canary or ring deployment where we're just doing gradual exposure of the feature and waiting for feedback, or running a beta program, the PMs will generally do that. Sometimes design will do that if they're trying out a new design. They might be at a meetup or something like that and want to flip on a new design for someone that's sitting in front of them, and we have the capability with individual user targeting to do that. So it all is primarily use case driven. And I think the big shift for us is when we bought into feature flagging as thoroughly as we have, as you'd imagine, because we're a feature flagging company, feature flagging moved into the planning process. So we describe the flags and the use cases for those flags around a particular feature when we're planning that feature.
Are there any technology or architectural trends that you're finding really interesting right now?
I like a lot of the kind of unsexy trends that are coming along. I mean, I think serverless is great. There are tons of people talking about that, but I really am interested in tools that are taking aspects of the process that are a little bit underserved right now. I mentioned a tool called Fire Hydrant. That's around a missing piece of the puzzle, I think, for incident management. You need PagerDuty, but then you also have this whole suite of processes around that, and Fire Hydrant has done a pretty cool job of capturing that. Another one is governance, risk, and compliance, right? That's extraordinarily boring. But those processes are actually really helpful at an organization, and it's not just about handcuffing you, it's about ensuring that you're following best practices. There's a tool called Zen GRC that we think is really cool that helps out with processes like that. So yeah, think about some of the processes that you're managing with tools like Confluence pages or just ad hoc, and imagine there was a purpose-built tool for that. I find those really interesting.
How do you manage turning a feature off if it contains transactional data which would be affected by turning the flag off?
That's a pretty tricky one. It depends pretty specifically on exactly what you're trying to do. I guess one way to think about it is like if you didn't have the feature flag there, what would you be doing? A lot of times the answer is you would have to code around that. And so I think like at some level you kind of have to handle that anyway. With transactions in particular, one thing that you can do is feature flag everything in the transaction consistently, so ensure that the entire transaction boundary has the same set of consistent flags. I'm happy to follow up offline if there's something more specific. It's a little challenging to answer that without a specific use case in mind, but it's a cool question.
That's all the questions we have.
Awesome.
Great. I'd like to thank you all for joining us. And John, thank you so much for your time. It was a pleasure talking to you and learning more about LaunchDarkly. We'll be posting a video of this for people that want to go back and check it out. And I'll tweet out the recommendations that John suggested in terms of books and podcasts and technologies. Thank you all. Have a great day.